Hi, welcome to the final seminar presentation. We are Group 4 and we are doing the phone engine assembly with the robot Epson T3 401S. In the group we are David Feu Galindo, Gabriel García Matei and Sandeep Samayal. First we are going to see the assembly process that will be done in this engine assembly. The assembly process is the same that we thought in the previous seminar. We are going to just go briefly. So first we place the keyboard, picking it from palette 1 to place it on the PCB. Then we will place the metal part that is also picked from palette 1 and place into the PCB. And you have to push so it will put the clips correctly. And at last we are going to pick the speaker and place it in the back cover. Now we are going to the gripper design. We have improved the design that we had from last seminar to have a more reliable design that will push better in the clips. As we can see from the first gripper design, we had only 2 legs. Now we have 4 legs, but they are placed right in the spot of the clips, so it's better for pushing and not pushing the PCB unnecessarily in the middle of the PCB. We also have holes, so in the sense of material it's more efficient. We have also removed 2 screws for fixing it to the flange, because we saw that with only 2 it's easier to put it on, put it off, and it's well fixed. And as we spoke in the last seminar, we had different parts from the vacuum than from the pushing part, so we redesigned the vacuum system using a smaller suction cap and a holder for the tube that goes from the tube that is giving vacuum. So now it's more fixed and more easily removed. And for that we only need to reprint this little part, not the whole design, as it's 2 different parts.
Now we can talk about our palettes. The palettes are mostly the same, the one we presented in the midterm seminar. The only change is the palette in yellow, the one in the right. It's different because the group 6 needed a different palette for the jigs, so they need to remove the sides, the walls where the pieces are, and then the only modification we did in both palettes is in the corners. It's possible to see some marks for the calibration of the robot. Those are the palettes now in real life, one in yellow, the new one, and then the black, a bit modified in this sense of the calibration points. In the capabilities of our robot is a SCADA robot. It's a 4-axis robot, has an excellent accuracy, 0.02 millimeters. The key point is that it's very sensible with rotation coordinates, with the 4th degree of freedom, the rotation. It's really sensible. And then in the visual components, the post-processor is not able to show correctly the rotation, the axis, because it's always putting the angles in a negative, and then the robot is not interpreting correctly these negative angles.
Hi, I'll be continuing with visual component simulation, calibration and robot programming, which we carried out throughout our completion of our project. So in this slide we could see a simulation from our virtual environment, and on the left side, and on the right side we could see a real robot running the program, fulfilling our assembly process as per our requirement. So let's look into that before I talk a little bit more about it. So as you could see from the video that we were able to achieve very quite good results, where the simulation and the real robot seems to be working exactly as we wanted. So there were few issues to achieve the result. So there were some of collision happening, there were some parts not placed exactly to the right position, and maybe also a little bit issues with the gripper. So we were able to fix all of those to achieve this result. So let's look into few of the problems and then how did we solve. So first was calibrating our parts so that our parts are precisely placed into exact location in the real world and in the virtual world. So we used calibration techniques from our lectures, and then we also needed to make sure our gripper is in the right orientation, because our real robot and our virtual robot, there was some mismatch. So we were able to measure the difference between the real and virtual, and we were able to give the offset so that it is oriented in the right orientation. Then there were few of the collisions happening during the assembly process, and those collisions were mainly between the metal part and our PCB part. So metal part and PCB part had a collision because they needed to be placed and pushed. So because our metal part needs to be tightly fixed with our PCB part, so there was some collision, and that is what we could notice in the video. So the tolerance level what we observed here uh, is around 0.3 to 0.5 mm, so that is quite very low tolerance. So I think we were able to achieve very good results and avoid any major breakdown or any major collision happening. So that is what we could observe here. And there were a few issues where with our program where we had to fix few of the things because our post-processing was not exactly precise. So we were able to do that, and we were able to achieve very good results at the end. So this is our end of the presentation. Thank you very much. Please feel free to ask some of the questions related to our topic. Thank you very much.